You're both bare. Put some bloody clothes on. Greetings, the Astro 30 here, and welcome back to AEL. Now, if you're new to this channel, please consider going down below and subscribing if you haven't done so already. Thanks. Today I've got a short little electronics fundamentals video for you today. We're going to look at potentiometers, and what I have in my hand here is a potentiometer. What is a potentiometer? Well, a potentiometer, often known as a pot, is this device which has a variable shaft here which varies the resistance between the contacts. Now, they're often used in a lot of electronic products for tone controls, volume controls, etc. And they are often marked what their value is. This says B50K. This pot's actually damaged. Now, the B means linear, and if it was A50K, then it would be logarithmic. And that's just the curve of how the resistance changes with the interaction of the turning of the shaft. Is it a smooth increase in resistance or decrease in resistance, or is it a more jagged increase, decrease? We have 3 pins usually on a single gang pot. You can have up to 4 gangs on one pot. What that means is you've got 4 separate channels. But we'll look at just one, and this pin here, which is now upside down, this is known as the counterclockwise position, which is when this is rotated all the way counterclockwise, this should be 0K, or, short. This is the wiper connection, the center pin, and the outer pin over this side is the clockwise position. So conversely, if this was rotated all the way clockwise, well, between the center pin, the wiper, and this outer pin should be 0 ohms. That's the theory anyway. There are some pots which are wired differently with their pin out, but every pot that's manufactured does have a data sheet, so you can always look at the data sheet to confirm what the pin out is. So I've taken the back off of this pot, and if you look closely here, this greyish bit, that's actually the carbon composites material. It runs around the whole circumference of the pot. One end is connected to this pin, the other end is connected to this pin. Here in the center you can see there's these little fingers which rub up against the carbon, and that is connected to this center pin. So we can get a difference between resistance between the center pin and these outer pins by measuring the result at the center pin. And if we measured one end here, well, the pot's more advanced this way, so the resistance between these 2 pins should be higher than the resistance between these 2 pins. And again, that should be even more higher, and that should be lower. If we rotate it the other way, it'll be lower here, but higher here. So that's basically how the pot works. Very kind of interesting, isn't it? To demonstrate this, I've got the multimeter in resistance mode with the positive terminal going to the center pin and the black is going to the counterclockwise position, and as I rotate this pot to the counterclockwise position, we can see the resistance is going down, and now it's at 0 ohms, or there, close about. So if I rotate it the other way, let the meter catch up, this is a 100K pot, and as I get to the other end, we're close to 100K. And if we were to measure between counterclockwise and clockwise, we should see the full 100K. And as we rotate the pot, that value does not change. Okay, so how can we actually use this pot in a circuit? There's really only 2 ways a potentiometer can be wired in a circuit. So I'll start with the more common one, which is seen on a lot of schematics. Is like that. Either way, it can be rotated in any direction. So here's the clockwise position, and here is the counterclockwise position if I wrote the correct letters. There we go. Which relates to an orientation of the pot like that. So counterclockwise down here, clockwise there, wiper at the centre. And this is known as a potential divider. So the resistance here is different to the resistance here at any given moment. And this would connect to one potential, say positive, and the other end connects to another potential, say ground. And the resultant output here, which is going to be out, between here and ground we're going to have a difference in voltage. Now be aware, running DC through a pot, especially one of these because they're only rated at half watt, you can only have very low current going through it or else you will destroy the pot. The higher the current goes, and if you exceed half a watt, it will start sending the magic smoke out the back of the pot. So you cannot use this to change the speed of, say, a motor, because the load of the motor will burn the pot out. You can, however, use this in a more traditional fashion that's not related to DC as a volume control. So you'd have your AC signal coming in here and you'd have a varied AC signal out by rotating the pot. The other way we can use the potentiometer is actually as a variable resistor by connecting the wiper to either the counterclockwise position or the clockwise position. So if we connect the wiper to the counterclockwise position like that, when we measure across these 2 points, when this is rotated fully counterclockwise, what we're going to see is the full resistance of that resistor. So say it was 100k, you would see 100k. And as you rotate it closer to the clockwise position, you'd get closer and closer to 0 ohms. So as you're increasing the pot's rotation, you're actually decreasing the resistance. Conversely, if we change where this is connected and we connect it to the clockwise junction instead, well, when this is fully counterclockwise and we measure between these 2 points, we will see 0 ohms, and as we increase, we will see the full 100k. I can demonstrate that now. So I've got the pot wired with the wiper connected to the counterclockwise position. The other end of the meter is measuring the clockwise position, and the pot is fully anti-clockwise, and as we can see, we've got 100k. As we rotate the pot, that value starts to decrease until we hit 0 ohms. Why? Because remember where the wiper is. So the wiper is now sitting close to this point here, counterclockwise. So we're actually, when we measured between that pin and that pin, the clockwise and the counterclockwise position, we had the full 100k of the resistance, and the rotation of the pot made no difference. But now that the wiper is also connected to the same point, as we're increasing the pot, that wiper is moving around the carbon track, effectively making the resistance between the carbon track and the center point less. And the more it rotates, the less it gets. And the opposite is true, that if we switch it around and change the center and outer pins, if I can get them to agree with me. I wonder if I can just short it with the meter. I believe so. So when we're at the counterclockwise position now, we're close to 0 ohms. As we increase the pot, so too does the resistance until we get the full 100k. For the same reason. So we can use this sort of idea to control the gain of an op amp, for instance, in the feedback path, or for some other control that the particular circuit it's in needs. But if you want to configure the pot to increase its resistance as a variable resistor, then the clockwise position and center have to be wired together, and the counterclockwise position is left open. And that's how a potentiometer works. Isn't that neat? Anyway, I hope you enjoyed this video. If you did, please remember to go down below, comment, like and subscribe if you haven't done so already. Anyway, this is Yashua saying see ya, have a great day, see you in the next one. Thanks for watching.